Welcome to my long promised chapter 4 lecture video on looping. So let's begin. Get my mouse going here. There we go. So what is a loop? Really, a loop is the combination of the other two structures in structure programming. It's a decision which drives the loop, and then some sequence of events inside the loop. And you can have nested fors and ifs and nested loops and all of that. It just depends on what you're doing, but that's essentially what it is, and it operates over and over and over again. For example, if you had a little robot that you were controlling through code, and the robot's software had a walk feature or step feature, let's say, it would take a step every time you told it, like step, right? And you put the robot on one side of a room, it doesn't know how many steps it's going to take because the rooms can vary, the room sizes can vary. So there's a sensor on this robot, and when that sensor gets up next to a wall, it's going to send information back to your program so that you can terminate the loop in which you're telling it to step. So that's an indefinite loop. The program doesn't know if it knew anything. Let's personify it for a moment. If it knew what was going on, and it really doesn't. There's no way for it to know beforehand, before it runs, how many steps it's going to take for that robot to get from one side of the room to the other, because it's all based on dynamics, different room sizes. If you didn't have a way of looping, then there would be no way for you to write the right number of step commands for different room sizes. And that's why you have to have loops. That's the main thing. And plus, even if you knew, if you had 10,000 steps in a huge room, you'd have to write step 10,000 times, which is untenable. Your code would be voluminous. So this way you have like 3 or 4 lines of code that keeps repeating over and over again. All right. Now, even if you know ahead of time a number of loops, that's called a definite loop, and use counters, and I'll show you how that works. So get that in your head. There's indefinite loops and definite loops. I'll let you go back. Make sure you read the book, the chapter, and watch these little videos. These are good. Here's a flow chart of a loop. You've seen these when we were doing structures, right? Or trying to structure an unstructured code. So this is your decision, and this is the stuff inside of the loop. Notice that the question gets asked again and again. Whoops, sorry. What did I do? Went backwards, I guess. So the sequence falls into this decision. Some condition is evaluated. If it's true, it goes over to here, does this. If it's not true or if it's false, it just continues on. All right, just the way it works. So this thing could keep looping and looping and looping and looping. Now there has to be some way for this to be false at some point, or you get what's called an infinite loop, and we'll look at that later. And there are while loops and for loops in most languages. A while loop basically says, do this loop while some condition is true. That way, when it's false, you don't do it anymore, it ends. And I'll show you a little flow chart of that too. So for a while loop to end correctly, a program must perform 3 separate actions. It must initialize a variable. That's the loop control variable. And I'll show you an example of that. Test the loop control variable in the while expression. Well, there's your decision, right? If the result is true, the loop body begins executing. Alter the value of the loop control variable so that the while expression eventually evaluates as false, and then the loop ends, basically. Now here's an example of that. The program starts, you declare your loop control variable, which is count, initialize it to 0. Then it hits the decision at the top of the loop. Is count less than 4? Well, is it? Yeah, right now it's 0. So yes, that's true. Goes over here, outputs hello, increments count, or adds to it. Now you can also decrement count, take 1 away from, or any number. It doesn't have to be 1. That's just what we use in these little examples. However, it has to be the same number every time in most instances. So count equals count plus 1. Now what does the value of count equal in memory? Well, it equals 1. We just added 1 to 0, right? So it comes back up here, asks the question again. Is count less than 4? Yes, 1 is less than 4, so that's true. Comes over here, does this, increments count again. Now what's the value of count? It's 2. right? 1 plus 1 is 2. So it comes back up here. You see how we're incrementing that? It has to be changed so that at some point this is false. You have an infinite loop. So here we go. Comes over to here. Is count less than 4? Yeah, it's 2. So it comes over here, does this again. Now it's 3. Comes over here. Is count less than 4? Yes, 3 is less than 4. So comes over here, yes. Output hello, count equals count plus 1. Now count equals 4, right? Comes up here, is count less than 4? Is 4 less than 4? No, 4 is equal to 4. So now this evaluates as false or no, and it stops. That's how a loop works, essentially. Okay, there are caveats to anything, but that's how it works. We incremented the loop control variable in this last example so that at some point the condition in the loop body would evaluate as false. You can decrement it. You can use something coming from the user like type yes to continue. As long as it's equal to yes, you keep going, and when it hits some other value, then it exits. It's called a sentinel value, but most of the time in what we're doing, we're going to be using a loop control variable, which is a number. We talked about definite loops, counted loops. We talked about indefinite loops already. So here again, they're just going over this. They're going to use an example of a sentinel value instead of a number. Starting value that will control the loop must be provided. It's the same idea, it's just a different value. So here we go, input response. So now what's driving this loop control variable, which is a response, is coming from the user. So response equal string yes, quote, close quote, yes. Is that true? If it is, then we come over here and we output this text, do some bank calculations, and ask them if they want to do next year's balance. If they input yes again, that means they want to do it. It comes over here, is response equal to yes? Well, if they input yes here, or Y for yes, I'm saying yes, but it's a single character. Then it comes over here and does next year's balance. Well, if they had input anything other than Y, typically N for no, but it could be Z space, whatever. As long as it's not equal to that, it's going to blow out. Because if let's say they just input an N, is Y equal to uppercase Y? No, it's equal to N. Have a nice day, and it goes on. Okay, so this is an example of a sentinel value. Same idea, same concept, coming from a different place. Okay, I'll let you make sure you watch these videos along with your reading of the text if you haven't done so. Nested loops. These are very important when you're getting into two-dimensional arrays. I have a little example of how that works, not with two-dimensional arrays. We only cover single-dimensional arrays in here, but we'll get to it. I think it's an in-class lab. It's not one I would throw on you. But anyway, it says it gets more complicated when you nest loops. When one loop is nested within another, the one that's the outer is called the outer loop, and one that's inside is called the inner loop. And I have some like I said, I have some assignments that'll make this a little bit more easy to understand. This is so far out there, I don't even think they give you an example of this. Okay. Here is a program that produces 100 labels. So these are some string constants. These are counter. There's a constant called labels. There's label counter, string name. These are variables, and these are constants here. Okay. Now here we're using a quit string. They have to enter ZZZ in order to stop this. That's probably because numbers won't work too well because they're doing counters and label counters and stuff. So you see there's a lot of different ways to do this. That is a sentinel value though. And quit is a name constant which holds ZZZ. So input name. If they type ZZZ to begin with, what would happen? This would just end. It would never go inside the loop. And I'm going to talk to you at the end of this about pre-test and post-test loops because I don't think they do that in the chapter, but I certainly do, and you need to know about it. So if they type in Tom here, well, is name equal to quit? No, it's not. So this is, you do this while something is false. So you can do it either way, right? So is name equal to quit, which is ZZZ? No, it's equal to Tom. So we're going to go in here and set a label counter equal to this, and then we have it. So this is a nested loop. It's one loop inside of another. So we got is label counter equal to labels, and labels is 100. Well, no, it's 0. Okay, so it can't be. It comes over here, does this, does an increments label counter. It's going to print 100 labels. At some point, label counter is going to be equal to labels, right? Because you're incrementing by 1. It comes over here and gets input name again, and it says if it's quit, because they could have put, ZZZ down here to quit, and obviously there'd be some prompts telling them that. And is name equal quit? Yes, out. Okay, so that's a nested loop. Those are nested while loops. Now let's look at the for statement. For is a little easier to do because once you set up the head of the loop, you don't have to increment the counter anymore. All right, so it initializes, evaluates, and increments or decrements, however you want to set it up. Now, for is keep this in mind when we get into pre-test and post-test loops. A for is always a pre-test loop. In other words, it always evaluates it at the top. So when we start talking about pre-test and post-test, just keep that in mind. All right, so for statements takes on this form. Now, different syntaxes depending on the languages. This is more like Visual Basic, especially with that step right there. But it says for initial value to final value. So we start somewhere, and we're going to go up to some other value. Or we could go high and go down to a low value and use a negative step, like a step -1. Now, step is optional as long as you're using 1. You don't even have to put it in there. But if you use anything other than 1, you have to put that step, you have to put the step keyword and then the value. And then the inside of it's what you do. So first thing that happens is it looks at the initial value, might have to initialize it to some value, and then it goes over to here and sees if it's equal to that. If it's not, comes inside here and does something. When it hits N4, it comes over here and increments by 1 because step value is set to 1. Then it comes over here and makes this comparison again. If it's true, it comes in here and does. So that keeps going until it does not evaluate it true. All right. For year equals 2015 to 2115, step 10. So we're incrementing our counter in steps of 10. All right. So you perform and display population calculations. So it just keeps going. So we know that the beginning year, this is the loop control variable, by the way. So it's initialized to 2015. This step only takes place once if you're going to do the initialization here. That's at the beginning. So first thing it does at the beginning is it initializes year to 2015. Then it compares 2015 to 2115 and see if if you've reached 2115 yet, because this is your start value and your end value. That's your comparison. So if it hasn't reached 2015 yet, it comes in here and does what it's supposed to do, hits the N4, then comes up here and increments year by 10. So what would be the value stored a year now? Well, 2015 plus 10 is 2025, right? So and then it makes this comparison. So does this equal? No. So it comes in here and does it again, increments it by 10, then to 2035, 2045, and then compares until it gets to 2115 or higher. At some point, this will be false and this will end. You can use a negative step value. Like I said before, you can start high and go low. But if you do that, you got to have a negative step value. You can do that. That's perfectly fine. There's nothing wrong with it. So counter starts out at 100 and goes down to 1 in increments of -1. So 100, then 99, then 98, all the way down to 1. When counter equals 1, then this whole thing is over and it ends. You can use a loop to validate data. We do this quite a lot, just to make sure they're giving you what you want. If they're not, you just keep looping until they do give you what you want, right? When the data is not what you're supposed to be, or it's not in some reasonable range that you're asking for, like enter a number between 1 and 10 and they put 50 in there. Well, you ask them to enter a number between 1 and 10, so you go inside of a loop, get their input, and you prompt them, give us an integer value between 1 and 10. And if in the loop that's not true, then you just keep looping until they give you what you asked for. You keep popping it up in their face, basically. And it's really important to get in the habit of thinking in terms of data validation, because you can blow a program up in a heartbeat if you're not ready to handle that stuff. And everybody has to deal with it. So you display the error message, assign the default value before proceeding, reprompt the user for valid input. So you're just nagging them, basically. You keep throwing that input screen up there, they'll eventually get the message. All right. You got a high month, low month here. Those are constants because they're uppercase. Low month is 1, high month is 12. if they enter a month that's outside of that range, you need to test for it. It says if month is less than low month or month is higher than high month, greater than, if either one of those are true, this is an if. This is actually an and, an or. If month is less than low month or month is greater than high month, either one of those are true, this whole thing is true, right? Remember the or? So if that's true, it's less than it's supposed to be. That's not in a valid data range. Or if that's not true, right? If that's not an issue, then you come down here and on the other side of the or and you test, is month greater than high month? If that's true, this whole thing is true, regardless of which one's true. They're either too low or too high, or it's okay. All right. What if both of these are false? Well, that's the only way that this or can be false, right? Which means what? They've given me a number between 1 and 12. Because this is false, it's not less than low number. This is false, not greater than higher number. So both of these expressions are false. The whole thing is false because that's the rules for an or. Come over here and there's nothing to do, and out you go. However, if either one of these are true, you come in here and you say, output, enter birth month, input birth. Now, this only works once. We're going to put ours in a loop. This is not a loop. This is a dual alternative if. But they're just trying to show you the logic. You could put this in a loop. It would be really easy to do. All right, and there they have it in a loop. Okay, and that's what you're looking at. Now they've broken it down to the point where it just keeps going until they give you what you want. Now, here's the thing. Most people look at this backwards. They get it backwards the first couple times they do it. What you're testing for is not if they gave you the valid number. You're testing for the exception. You want to know if they gave you an invalid number. An invalid number is what? Less than 1 or 0, an integer, or greater than 12, 13, or higher. All right. Either one of those situations is true. Scenario, then you need to loop again and ask them. A lot of people will sit there and say, oh, if they've given me this and they give me this, then that's great. And they keep looping when they should be blowing out. All right. So remember that. You're testing for the exception, not the rule here. All right. Now let's look at something else. I want to talk to you about pre-test and post-test loops because that works really well when you're doing data validation, but you need to know the difference. Now remember I said in for loop is always a pre-test loop, meaning pre-test means it tests at the top of the loop, right? Post-test means it tests at the bottom of the loop. Matter of fact, let me move this right here down to here. This is just a comment just so you can see what's going on. This is a do-while loop, all right? This is just pseudo. So I have the loop control variable called x. I have initialized, it's a number, and I've initialized it to 0. Now, probably need to show you something else here in just a minute. Do while x is less than 5. Well, this is a pretest loop because before this loop starts, this is examined. Well, what if x equals 10? Do while x is less than 5. Well, is this true? All of a sudden, no, it's not true. Because x is equal to 10 up here. Well, it's just going to not go in the loop and move on down, all right? So that is the pretest. This is at the top. Let's set this back to 0 here. All right. Now let's say that this is true. X is equal to 0. So that means x is less than 5. So you do this loop while x is less than 5. And notice I have an increment statement in here. Do while x is less than 5. That's true. X is less than 5, so it comes inside here, and I can have all kind of code in there. I just happen to put this, just one line in there. So x equals x plus 1. X starts out at what? I'm going to put some code. Let's put a counter over it. This is just, I'm going to put this out here. Starts out at 0, then it increments by 1. So now what does x equal? 1. Okay. Once it hits the bottom of the loop, comes back up here, tests it again. Is x less than 5? Yeah, x is 1. 1 is less than 5. Comes in here again. It's going to increment my code. It's going to do it again. And it's going to do it again. It's going to keep going until that condition up there is no longer true. Let's just stay with 4. So we've been in here several times, and x is now equal to 4. Comes back up here and tests, is x less than 5? Well, if it's 4, it's less than 5, so that becomes true. That evaluates as true. So it comes in here, now x is equal to 5. Let's see if you can figure out what's going on here, besides the fact that I can't type. Do while x is less than 5. Well, okay, let's make the comparison. Is x less than 5? No, it is equal to 5. So this is false now. Okay, so you do this loop while it's true. Well, this is no longer true, so you no longer do the loop, so out you go. All right? Got me, you with me so far? That's a pretest loop. Now, here's a little problem you might run into. If this were real code, and I started into this loop, x would now be what? 5. It wouldn't be 0 because I just used it in this code up here, so I'd have to reset it. All right? X equals 0 again. So now x is back to 0. Now this is a post-test loop. Notice the condition is at the bottom. So when you first hit the top of this loop, it doesn't make any difference what x equals because it's not being examined until it gets to the bottom of the loop. So x could equal 1,000, and it wouldn't matter. Whoops, wrong one. It wouldn't make any difference, right? Because it's not looking at it here. It's falling in down here and doing this, and then now it's 1,001, right? Do this while some condition is true. Well, is this condition true? No. X now equals 1,001, which is not less than 5, so this whole thing blows out because that evaluates as false. Now let's take a look at something here. What's the real difference between a pretest and a post-test loop? Most people will say, well, one evaluates at the top, one evaluates at the bottom. That is a difference, but that's not the seminal difference. For you as a developer, software developer, programmer, you need to understand that if it's a pretest while loop, it may or may not ever go into this loop. It all depends on the value of the loop control variable because it's evaluated at the top. Like I showed you before, if x equals 1,000, this is false. It never goes into the loop, so whatever you have in here will never get executed. However, you can rest assured that with a post-test loop, it will always enter the loop at least one time. That has its uses, right? Obviously. So no matter what the value of the loop control variable is, in this case x, it doesn't make any difference. It'll come in here and run all your code at least once, and then it might exit, or it might keep going, depends. So that's the seminal difference, the primary difference between these two. Pretest loop may or may not ever enter the body of the loop. Post-test loop always enters the body of the loop at least once. Okay? How about that? Now let's see. I will see you in class.